Hey guys, it's your boy Easy and welcome to Easy's Garage. So a few of you have asked me about my fog lights, specifically how I wired them to my bike. And when it comes to wiring up aftermarket electrical accessories, I know a lot of people are apprehensive about doing it themselves because they're afraid of messing up the bike's electrical systems. So today I thought I'll do a classroom style video where we'll explain the basics of the motorcycle's electrical systems and how to safely wire up any kind of electrical accessory, be it a low to medium powered one like this USB fast charger, or a high powered one like some high wattage fog lights. So hopefully by the end of the video you'll have an appreciation for the way the bike's electrical systems have been designed and protected, and you'll feel confident enough to wire any combination of any accessory that you may have. All right, let's move to the classroom. For purposes of this video, I'm going to be using this USB charger, which comes with the needed wiring, black for negative, red for positive, as well as my high wattage fog lights as examples in all the wiring diagrams that I'm going to show. Before we get started, two disclaimers. One, I'm going to be talking about electrical circuits in general, fuses and relays and what they are and how they work in some detail. So it might be slow for a lot of you guys who already know that kind of stuff. So I apologize in advance. Feel free to fast forward to the part of the video where you'll find the information useful. And two, this video is not about crimping and splicing and tapping wires and how to do it correctly and what connectors you used to use and that kind of stuff. I will touch upon that later on in the video, and I'll show you some of the connectors I like to use and the ways I like to tap wires. But I'll add some links in the description below to videos from other channels that show you how to do that properly and what kind of connectors you can use. Okay, let's get started. So when I'm wiring accessories to my bike's electrical system, I like to follow some principles or guidelines, if you will. One, always protect from a short. So you don't want a short in your circuit or a fault in your accessory to cause overheating and a sudden current surge and cause a fire. So always protect from that. Two, always wire your accessory in parallel. So for if something's wrong and your accessory fails and your circuit breaks, you don't want that to affect any of the accessories that you may have powered, and you definitely do not want to affect some of your bike's crucial electrical systems. Three, oftentimes you'll have to tap into an existing circuit or wire to power your new accessory. So when you're doing that, make sure that the wire that you're tapping into is capable of handling the additional current draw because of the new accessory that you're wiring up. So for example, if I'm tapping into a wire that's capable of handling 10 amps of current, I'm not going to hook up fog lights to that because for sure fog lights are going to require more than 10 amps. And so that'll definitely cause a break in your circuit. And four, most if not all accessories that you buy will already come with appropriate sized wires to power that accessory. So fog lights, for example, will come with thick wires, and really low powered USB chargers or like some LED lights will come with some thin wires. But there are times where those wires may not be long enough and you may need to extend it depending on where you're installing that accessory on your bike. So when you're extending that wire, obviously use an appropriate sized wire to extend it. So do not extend your fog light wires with a thin wire. That for sure will not work. If you can think of any more guidelines that are good to follow, feel free to leave a comment in the comment section. And then we'll talk about the three different powering options. So one is if you want your accessory to be powered even when the bike is off and the ignition is off, you can hook it up directly to the battery. Be very intentional about this, because if you're not careful and if you don't add a switch that you can turn on and off the accessory, you can very quickly drain your battery. So avoid this as much as possible, but there are instances where you may want to do it, so be careful when you're doing this. The second option is powering your accessory as soon as you turn the ignition key on. I'll show you how to do this as well. This is pretty common, I think, and a lot of people do this. But again, you got to be careful because I've seen a lot of people, when they finish riding, they leave the ignition key on and they may go for a coffee break or something, and then your battery will still continue to drain because your accessory is still drawing power. The third option is what I like to do, is basically power my accessories only when the engine is running. And so even by mistake, if I just leave the ignition on, the accessory is off and it's not going to drain any additional power from the battery. So it removes any human error out of the picture. Let's look at the first powering option, which is directly from the battery. This is the easiest one to wire up. So here we have your 12-volt battery, which is powering up all your electrical systems on your motorcycle, your lights, your dash, your horn, your ignition coils, your fuel injectors, your starter motor, all your sensors, etc., etc. Here I've oversimplified it and I'm just showing you, for example, the tail light, and the power delivery is controlled by the ignition switch right here. In reality, it's much more complicated than this, and there's a lot more protections in place, which I'm not showing here. Now, if I wanted to power my USB charger directly from the battery, again, I would just hook it up straight to the battery terminals. Again, I would add a switch so I can turn my USB charger on and off, and it will be connected directly to the positive and negative terminals of the battery. This USB charger circuit is automatically wired in parallel, so even if there's something wrong with it and the circuit breaks, my USB charger will stop working, but the rest of my electrical systems will continue to work because they're completely separate circuits and systems. However, I still haven't protected my USB charger circuit from shorts, and shorts can happen because of exposed or faulty wiring in the circuit, or sometimes even poorly manufactured devices can create a short. And you don't want that to happen because a short will cause an overcurrent in this wire, which will cause it to heat up extremely, and then it'll cause it to burn. So to prevent that, you can add a fuse between the positive terminal of the battery and then your accessory. What the fuse aids in doing is it prevents the current from exceeding a certain amount. So as soon as the current reaches a certain amount, it'll break the circuit right here, and it'll prevent overheating. This is what a common automotive fuse looks like. There's a metal strip inside which will break as soon as the current reaches a certain amount. So this fuse is rated at 10 amps. So as soon as the current reaches 10 amps, the fuse will break and it'll break the entire circuit. So your circuit will stop working, your USB charger will stop working, but at least it won't overheat and it won't burn off. And the cleanest way to wire up a fuse to your circuit is by using a fuse holder like here. So one end of this wire will connect to the positive terminal of the battery, and the other end will connect to the switch. Now, how do you know what size fuse to use? How do you know whether you should use a 10 amp fuse, a 3 amp fuse, a 20 amp fuse, etc., etc.? So most electrical accessories that you buy, in the technical specifications, they would have listed the current and voltage requirements. For example, this quad lock wireless charger here clearly states that it draws a maximum of 2 amps. So to be safe, I would just add a 3 amp fuse here, and I'd wire up this quad lock wireless charger with a 3 amp fuse. So even if there's a short in the circuit, as soon as the current reaches 3 amps, which is much more than the charger needs, it'll break the circuit and it'll prevent a short. However, not all accessories have their input current requirements listed out. For example, the USB charger that I have, nowhere does it list the input current. All it states is the maximum power that it outputs to the devices, like my phone or whatever it's connected to it. In this case, it's 55.5 watts. And from that, actually, that's enough to calculate the current that it's going to draw. So if the way we do that is, if it's going to output 55.5 watts, it's likely going to need a little bit more power from the battery, because no device is 100% efficient. So if it's going to output 55.5 watts, assuming it's 85% efficient, which is a fair assumption, it's going to need about 65 watts from the battery if it's going to output 55.5 watts. This is an assumption that it's 85% efficient. And this is one formula you need to know, or you probably learned this in school, is P equals to VI. P is power, V is voltage, I is current. You know the P, which is wattage. You know the V, which is voltage, which is 12 volts. And so I is easy to calculate. I is P over V, which is 65 divided by 12, and this is 5 point something, let's say 5.4 amps. So now I know that this USB charger is gonna need 5 point something amps running in this circuit, and so what I would do is probably add a to be safe, I would probably add like a 7 amp fuse or a 7.5 amp fuse or something like that. So if the charger is functioning properly, it's drawing 5 point something amps, and the fuse won't break and the circuit won't be broken. But as soon as there is a problem with the charger or the wiring, the current will shoot up, and as soon as it reaches my fuse limit, which is 7 amps or 7.5 amps, that fuse will break and it'll break the circuit. So it'll prevent a short. A lot of accessories these days, like this USB charger, actually come with a fuse and inside a fuse holder already connected, so you don't have to worry about adding a fuse yourself or calculating what size fuse you need to use. So here it is on the positive cable, the one that connects to the power, and this is the fuse. This is a different type of fuse, but it still is a fuse, and we can check it out. There's the fuse holder. You just open the fuse holder, and then the fuse is inside. So this is the fuse. So chances are the accessory that you have will also have a fuse, but if it doesn't, then go ahead and add your own fuse. And if I wanted to wire up fog lights to the battery, I would do the same thing. I would connect it to the terminals of the battery with the thicker wire, obviously, and control it with a switch, and just hook up the fog lights to the positive and negative terminals of the battery. Don't forget to add a fuse to the fog light circuit. You will need a bigger fuse this time, maybe a 15 amp fuse, depending on how powerful your fog lights are. And now if the fog lights for some reason stop working, your USB charger won't be affected, and vice versa. If your USB charger stops working, your fog lights won't be affected. There is a caveat when wiring these mechanical switches in this fashion, especially to power high-powered accessories. Most mechanical switches that you buy off the shelf are not rated for high current usage. They can only handle up to a couple of amps. So if you buy your mechanical switches separately to power your accessories, they likely will burn out or wear out over time if stressed under high current. So just make sure you buy a heavy-duty switch to power high current accessories, or if your switches came with the accessories, they likely will be able to handle the high current, but just make sure. If you want to power your 120 watt fog lights, for example, that will require a high amount of current, and you want to control it through a switch that can only handle a small amount of current, you can do that through the use of a relay. A relay is just an electrical component. It's basically an electrical switch that is specifically made to handle high amount of current. For example, here, most automotive relays can handle between 20 and 30 amps. You can get different size relays to handle different amounts of current. And the switch in this relay is actually, instead of being controlled mechanically by you pressing the button, it's controlled by current in another neighboring wire right here. And it's actually a coil inside next to the switch right here inside the relay itself. And passing current through this relay, through the coil, will create a magnetic field, which will then push the switch down to close the high current circuit. So you can pass a low amount of current in this circuit, and that will cause this switch in the high current circuit to close, and will then complete that circuit. And this relay coil, this coil here is a relay coil, and that's usually just requires a very small amount of current, typically 0.1 to 0.2 amps. So the way you would wire up your fog lights with a relay would just be to use your thick cables or your thick wires to connect your positive terminal of your battery to the relay, and then from the output of the relay to your fog lights. and then your fog lights to the negative end of the battery. And then you need to control the switch with current in this relay coil. So what I would do is then I would use my thin wire, hook up my mechanical switch, which can handle a small amount of current, to the relay coil, and then the other end of the relay coil I would connect it to the negative terminal of the battery. This relay switch here is normally open, so this circuit is broken, so the fog lights will not be powered. And my mechanical switch here is powered by this thin cable. When I physically press the button to close this switch, current will then flow in this circuit through this coil, and it'll push this switch in the relay to make contact and close this circuit, and then that'll power my fog lights. So my switch won't wear out because only a small amount of current is flowing, but my fog lights are getting a high current in its circuit. A relay, however, doesn't protect from shorts in your circuit. It just provides a means of controlling one high current circuit through another low current coil. So you will still need to add a fuse to protect from a short. So I'll add a 15 amp fuse here. So just in case there's a fault in your fog lights or there's some exposed wiring here, this fuse will still protect from a short. And say you're using a 30 amp fuse, so the fuse is able to handle 30 amps of current, and your current fog lights are only using say 10 to 12 amps of current, and you wanted to add another set of fog lights, you don't need to add another relay. You could just add your fog lights in a parallel fashion right here, so fog light number 2, and connect this to the negative terminal. So what would happen is as I close this switch, the mechanical switch, physically by pressing the button, current will then pass here and it'll control both these fog lights. What I would then need to do is remove the fuse from here, put it here instead. So this circuit is protected by a 15 amp fuse, and then I would add another fuse here, another 15 amp fuse here, which will protect this circuit from a short. So if this circuit fails, this fog light will continue to work, and if this circuit fails, this fog light will continue to work. And this is what a typical relay looks like. You can see the relay with the 4 metal pins, and instead of wiring up a relay with the metal pins directly to your wires of your fog light and your switches, the cleanest way to do it is with a relay socket, which is also shown here. So you plug this relay with the metal pins into the socket, and then the socket has 4 wires coming out, as you can see. 2 of the wires are thick and 2 of the wires are thin. So the thick wires are obviously meant for the circuit that's carrying high current, and then the thin wires are connected to the low current circuit. So those are for your relay coil. So the 4 metal pins of the relay each have a number associated with it, the relay pin number, and that's just to identify which pin is connected where in your circuit. So pin number 85 is always connected, is the relay coil pin, and that's always connected to the negative terminal of your battery. Pin number 86 is also for your relay coil, which is connected to the positive terminal of your battery. So these are the 85 and 86 are the pins that's connected to the circuit carrying low current for your relay coil. And pin number 30 and 87 are your pins that are connected to your high current circuit. And 30 and 87 can be interchanged, so you could connect 87 here and 30 here, or 30 here and 87 here. That doesn't matter. But for the relay coil, it's important that 85 is always connected to the negative terminal and 86 is always connected to the positive terminal. Okay, so let's talk about powering your accessories when the ignition is on or when the engine is running. Luckily, the wiring principles or guidelines are pretty much the same as when powering directly from the battery. That means you'll still have to wire in parallel, you'll still have to protect your accessories with fuses, and you still have to use relays when powering high wattage accessories. The only difference is, instead of powering from a battery, you'll have to find another circuit on your bike that only receives power when the ignition is on or when the engine is running. Luckily, most bikes, I would say in the last 10 years or maybe even longer, have a dedicated accessory connector somewhere on the bike, or some bikes may have two. And that connector, as I've shown here, is a 12-volt power source, specifically to power aftermarket motorcycle accessories. So it's isolated from all the other important electrical circuits in your bike. So as much as possible, I would try to use this power source to provide power to my aftermarket accessories. This will usually be located under the seat, sometimes in the headlight housing, and for the Himalayan, it's located on the left side underneath the tank, as you can see here. This accessory connector is usually always protected with a 10 amp fuse, sometimes a 5 amp fuse, and you can check this by looking at the fuse box on your bike. So the Himalayan fuse box is under the seat, and you'll see the 10 amp accessory fuse there. So this circuit is protected with a 10 amp fuse. On the Himalayan, this connector, it provides power only when the engine is running. So even when you turn the ignition key on, this connector does not provide power. But most bikes, I believe, this accessory connector or auxiliary connector will provide power as soon as you turn the ignition on. And I'll show you how we can check which of these two cases will be on your bike, whether it is providing power when the ignition is on or whether only when the engine is on. Now, to power up your accessories, it's exactly the same as before. So if you got a low powered accessory, for example a tiny USB adapter, a USB charger that only uses up 1 or 2 amps, you can power it up directly to this accessory connector. So I would just power it up like this with my USB here, and then connect the negative to the negative, and that's all you will need to do. I don't even need to provide a switch here, like in the previous case when connecting directly to the battery, because this USB will only get powered when the engine is running. So as soon as I turn the engine off, there won't be power and I won't be draining my battery. And if I wanted to add another low powered accessory like another USB adapter, I would just wire it up again in parallel. So I have a USB, another one here, and same thing, negative to negative. And then don't forget to obviously add your fuses, maybe a 3 amp fuse here and a 3 amp fuse here. So if any one of these USB devices causes a short, only one of these fuses will blow, and then the other USB device will continue to work. Now this is safe to wire it up this way because both your accessories, in this case the USB chargers, are using or drawing small amounts of current, at most 4 to 5 amps in total. And since your accessory connector is protected with a 10 amp fuse, this should be pretty safe to do. But the moment you're gonna wire up more accessories, or you're gonna wire up fog lights that will require a lot more current, just like before, use a relay. So here's an example of wiring up 2 fog lights here. I've used a 30 amp relay here, and that relay coil is only triggered by power coming from the accessory connector. Again, this power is only on when the engine is running. In the case of my Himalayan, in your bike it could be when the ignition is on. And so when I hook up my relay coils to my accessory connector, positive to positive, negative to negative, as I've shown here, that will cause the relay switch to close right here. My relay, the high current pins of my relay are connected to the positive terminal of the battery right here. And the other end of the relay, that's going to my 2 fog lights. So I've got one circuit for fog light 1 that's coming here, and that's protected with a 15 amp fuse and also a mechanical switch to turn the fog light on and off. And in parallel, coming from the same relay output, I've got another circuit for my second fog lights right here, again protected by its own 15 amp fuse and its own mechanical switch. So when the bike is off or my engine is not running, none of these fog lights are getting any power. But when my engine is running, the relay is activated, and both my fog lights are getting power, and both can be turned on and off individually. So I can have both of them on, or I can have just one on and the other one off, because I've got two switches here controlling them separately. And if one fog light fails, the other one will continue to work, because I've got two fuses protecting them separately as well. Since the relay coil is only drawing about 0.1 to 0.2 amps, and that's drawing it from the accessory connector, my accessory connector fuse will not blow, because very small amounts of current are flowing through it, and the heavy current is actually flowing directly from the battery right here. So here we have two high-powered accessories and two low-powered accessories, and this is how you could wire them up to your accessory connector safely. But you can imagine all the wiring and the fuses and the relays can look messy, especially if you're doing it under the seat or under the tank. And imagine now adding one or two more accessories, where you have like 5 or 6 electrical accessories that you have to wire up. Just imagine the amount of fuses and relays and wiring. So it can look pretty messy, even though it is safe to do. The cleaner way to do it, at least the way I would do it, is I would use a dedicated power distribution module. And that a power distribution module, which we'll talk about later, actually has all the relays and fuses built inside this tiny little box, and that box can power up to like 6 or maybe even more different motorcycle accessories, and you can set different current limits for each accessory, and it's got all the protection built in. So it's just a cleaner way of wiring things. The logic is essentially identical to what I've shown you here in the schematic. It's just the wiring is just a lot cleaner when you actually go to do it. So think ahead. Just think how many accessories you're likely going to wire up to your bike. And if you're just going to wire up one or two, like a USB charger and a fog light, for example, then you definitely do not need a power distribution module. You could just do it just like this. You just need one relay. But if you're planning on adding a lot of accessories in the future, then I would suggest go ahead and buy a power distribution module. So this is one example of a power distribution module. This is from Rowe Electronics, and it's called PDM60. I'll put a link in the description to this product. You can buy it on Amazon, eBay, and a whole other bunch of other sites. And there are other power distribution modules from other companies that work in a very similar way. This is one that I have experience with. I had this installed on my previous bike, my Indian Springfield, because I had a lot of accessories on that bike. And this is just a clean way of wiring up all of that. So you can see it here on the left. And this can power up to 6 different accessories of varying current requirements and power requirements. And on the right, you can see how clean it looks when installed on the bike. It's just one little box, and there's no external fuses or relays and all that kind of stuff, because everything's just built into that one little box. So this is how you would wire up your PDM, your power distribution module, and how you would configure it. You'd obviously connect it to the battery directly, so it's getting high current. And then it's got 2 triggers, IT, which is ignition trigger, and GT, which is ground trigger. So IT, I would ideally connect to my accessory connector, so my PDM knows when my ignition is on or my engine is running, depending on when your accessory connector is getting power. And then you got six ports where you can connect your 6 different accessories. So here it's got 2 aux lights connected to port 1 and port 2, and you would just connect it straight to the wires coming out of the PDM, and then the other end of the aux light will be connected to ground right here. Ground is just the negative terminal of your battery or the frame of your bike. And you can configure this using software, so you can set different current limits for all your different circuits. So for example, on circuit 1, if I've got a small USB charger that requires no more than 2 amps, I would set this current limit to 3, for example. And for circuit 2 and 3, say I've got fog lights, I would maybe set these to 15 and 15. And so you can configure this however you want. For example, if I want my USB charger to always get power even when the ignition is off, I would change this from ignition trigger to always on. And for my fog lights, if I want them to not get power when the bike is off, I would leave it as ignition trigger. So only when my ignition is on, these two will get power. So as you can see, this is highly customizable. It's very clean. This is what it looks like on the bike. No fuses, no external fuses, no external relays. So I would recommend this if you're wiring up a lot of accessories. Before we move to the motorcycle, I think it's a good idea to understand the basics of your motorcycle's different electrical subsystems and how they're powered and when they're powered and how they're protected and isolated from each other. So just in case your motorcycle does not have that accessory connector where you can get a 12-volt power source on ignition on to power your motorcycle accessory, you'll know exactly where to tap into your bike's electricals to get that 12-volt switched power on ignition on, and you'll feel confident that you're doing the right and safe thing. In the previous video about cleaning and greasing motorcycle relays, we saw that the Himalayan has 5 relays: the starter motor relay, the main or the EFI relay, the radiator fan relay, the fuel pump relay, and something called a miscellaneous relay. And each of these relays is responsible for delivering power from the battery to a different part of your motorcycle's electricals and different electrical components. So starter motor relay obviously is responsible for delivering power to the starter motor. The main relay is the first relay to get powered, and that's why you can see it is triggered by the ignition switch, and that's what's connected to the relay coil. And every bike will be the same. Every bike will have a main relay, and that's the first relay to get power directly from the ignition switch. And you've noticed the color codes, the yellow lines actually and the red lines don't mean anything. It's actually the thickness. So the yellow lines are like low current thin wires, and the red lines are high current thick wires. That's why you can see that the high current ones are always connected to the relay switches, and whereas the yellow ones are connected to the relay coils and also to the ECU pins. ECU is the computer of the bike, and that's what's responsible for reading the signals from your sensors, your crank position sensor, your throttle position sensor, oxygen sensor, and all your switches, side stand switch, brake switch, etc. And then that'll turn on and off the relay coils, or so this right here will tell the main relay that, yep, you're good to go, you're good to provide power to the rest of your bike. If you notice here, the main relay gets power as soon as the ignition is on, but the miscellaneous relay only gets power when the main relay is on and when the engine is running, which is the signal provided from the ECU. So the main relay powers basically all of your bike's electricals. So right here, the injectors, the daytime running lights, the horn, and everything else. And your miscellaneous relay powers your accessory circuit, which we talk about, as well as your low, high beam lights. And each of these different electrical subsystems are protected with their own fuses, right? So now we've talked about how we can get power when the engine is running for your Himalayan, which is just tap into this circuit right here, right? But how do we get power when the ignition is on? Now, there are plenty places you can just tap into, and every place will give you a 12-volt source. So you can tap into here, obviously, because this main relay output will get power as soon as the ignition is on, as long as the ECU is working fine. So you can tap into here. There's nothing wrong with that, and you can power your accessory from here. But then you can see that downstream, everything else is dependent on this connection, right? So your injectors, your horn, everything basically. So I usually don't like to tap into there. I like to pick the least crucial part of my bike's electricals and then tap into that. So for example, my daytime running lights or my horn, I know that if I tap into here, for example, if I want to power a really low powered USB charger, I could technically just do this. I could just tap into here, I'll put a little fuse here, like a 2 amp fuse here, and put my USB here, and then connect this to ground. I could do this and it should be fine. And if anything does go wrong here, like if I do mess up or for whatever reason shit happens here, then I know that the rest of my bike's electricals will be fine. It's only my horn that will stop working, right? So that's what I like to do. That's the principle I like to follow. That I like to pick the least crucial part of my bike's electricals and tap into that. And this is obviously for a low current device. But if I wanted to power like fog lights on ignition on, I would do the same thing but with relays. I would use this to trigger my relay, right? Get my relay here with my coil, ground this. For my fog lights, again I will connect this to ground, and this I would connect to my battery. Don't forget to protect it with a fuse. I'll put a 15 amp fuse here. So that way, this I know, like even if I do mess up something here, my fog lights will stop working. Maybe my horn will stop working, but the rest of my bike's electricals will be fine. So that being said, let's move to the bike now, and I'll show you where you can confidently tap into a 12-volt switched power, and how you can do that safely. I'll quickly like to show you like the type of connectors I like to use when splicing and tapping into wires. So I used to just use the regular butt splice connectors, these ones right here. And then say you want to join these two wires, you would put this in here. There's a metal contact in here, right? And then you put the other end of this wire in here, and then you would need a crimping tool to then permanently squeeze this and this end in, so it'll hold the wires in place tightly and it won't be able to come out. Again, I'll put a link in the description to videos that show you all the different kinds of connectors and how to use these crimping tools and that kind of stuff. And these are pretty effective, but you would need like these special crimping tools, and it's permanent. When I say permanent, that once it's fixed, you cannot reuse these connectors. If you want to remove the wiring, you'll have to cut the wire and you'll have to throw this away and then use a new butt splice connector. So these are kind of one-time use only. But then I came across this thing called Posi Lock. It's from a company called Posi Products. And the reason I like it is because you don't need any special tools and you can use it multiple times. So I'll show you how this works. Say I want to connect these two wires. On either end, you can remove this. And I will put one end in here until it comes out here, and then you see there's a metal contact here, and then so what I will just do is just try to squeeze this in, and now this is locked in place. The wire won't come out at all. And then the same thing I would do on the other end. Okay, there you go, and this is locked in. It's pretty secure. It'll never come out. I've never had any problem with this. I've been using these for the last like 5 years or so. They're not waterproof again, but again, it's if you're hiding it under your tank or under your seat, shouldn't be a problem. And then if you ever want to break this connection or remove this, you can just take it out of that, and then you can reuse this. So it's not one-time use, it's multi-time use. So that's why I like this. So now let's talk about tapping into an existing wire. So say for example, this is your 12-volt switched power. So this wire gets power when the ignition is on, and you want to tap into this. There's another product again by the same company, Posi Products, and this one's called Posi Tap. And the difference is one end is still like the Posi lock. So this is in, and now say I wanted to tap into this. So assuming this is not exposed, I want to tap into this. The other end is actually a pin, and it's got this little slit in this cap. Posi Tap connectors come for different size wires. So this wire will sit into this right here, and I will screw this in right here, and as I screwed in, this pin will poke into the insulation of the wire and it'll make contact with the metal inside the wire. This is what it looks like. So say this is my 12-volt switched power that I want to tap into. You can just screw this in one end, and the other end is your accessory cable, your accessory power. So now this is tapped into this existing circuit, and this is so clean, and it's pretty secure. And I've never had problems with this for the last 5 years. And again, if you want to remove this accessory, it's quite easy to do. Just take this out. The only caveat here is when you do take it out, there will be a tiny hole in the insulation. So that's one thing you got to be aware of. Ever since I discovered these Posi Tap and Posi Lock products, I stopped using these butt splice products. Even though these are quite effective, it's a little bit too much work for me, and it's permanent. So I like these Posi Tap products. They've been working well for me. So I'll put a link in the description where you can buy these. So here we have my bike, and I just want to show you my fog light wiring. Unfortunately, I didn't do this myself. I had the shop do it for me because I was in a bit of a hurry that day. But if I'd done it myself, I would have videoed the whole thing. But anyway, the shop did a pretty good job. They did it exactly how I would have done it. Anyway, the kit, the harness that comes with the fog lights is pretty plug and play, so not much thinking to do. But I'll just show you how it is. So this is the relay. So remember, fog lights are high current drawing accessory, so we need a relay. There you go. And this is the relay socket. And let me just plug this back in. And on the other end of the relay socket, there'll be 4 wires. Remember, 2 for the relay coil, 2 for the high current circuit, and it's all inside this harness. And the high current wires, they'll be exposed. So all we need to do is hook it up to the positive terminal of the battery, and then one to the negative terminal of the battery, which is hooked up right here. The wire that's connected to the positive terminal has a fuse that came with the fog light, so I'll just show you that. There you go. So this is the fuse holder, and inside here, there you go. And let's see what size fuse this is. Yep, it's a 15 amp fuse. So just like I showed you in the wiring schematics, the positive has a fuse to protect the fog light circuit from a short, and then the relay coil, one of them I've actually wired it under the tank, and the accessory connector is on the left side under the tank right here. So I've connected one of the relay wires, the other one that's exposed, I've connected it to the positive of that relay connector right there. And that relay connector only gets power when the engine is running, so my fog lights only get power when the engine is running. And that's all, actually. Super easy. If I wanted to power my fog lights when the ignition is on and not when the engine is running, so I wouldn't be able to use that connector. I would have to find a 12-volt wire here when the ignition is on. And just like we discussed, it's better to know where to look than to keep guessing until you find one. So know where to look. As I mentioned, you could tap into the output of the main relay. It's also called the EFI relay. So this is the relay. If I pull this relay out, so I've actually pulled out the miscellaneous relay, the 4th relay, just because it's easier to film. But you'll need to pull out the first relay right here. That's the main EFI relay. And actually you're pulling out the holder from this bracket here. Again, refer to my previous video on cleaning and greasing the relay pins. I'll put a link in the description. And pulling it out from the holder will expose the 4 wires underneath here. And those 4 wires correspond to the 4 pins that the relay has. So the relay, and this is the relay socket, remember, just like I showed you earlier. So find port number 87, which is the relay output, and find the wire that corresponds to that, and then you can tap into that wire. Again, not for the miscellaneous relay, but for the main relay, which is the first one right here. The first relay. There you go. Okay, so that's one way to do it. What I like to do is actually tap into the circuit that's non-crucial, and that gets power when the ignition is on. So if you look here in your fuse box, accessory fuse 10 amps, which is the fourth one from the top, this one right here, that only gets power when the engine is running. And so does this one, the fourth one from the bottom, this 5 amp fuse here, that's for your low and high beam. That gets power when the engine is running. So find the one that gets power when the ignition is on. There are quite a few, but like ABS motor and fuel injectors and all that kind of stuff. But I like to just use the horn, which is this 10 amp one here, the third from the top, or the third from the bottom, 5 amps, which is it's called the Posi lights. It's actually the daytime running lights of your headlight. So that gets on as soon as your ignition is on. And there's a way to test this. So turn on your bike's ignition first. Get your voltmeter ready and set it to measure voltage. So I'm going to touch my negative terminal of this voltmeter to the frame of the bike, and first I'm going to test the accessory fuse, which is the fourth one from the top. So there's a little metal one here, I can test it, and you can see the voltmeter is saying 0. Same with the low beam, high beam, you can see it's still 0. So there's no power in the low beam, high beam, as well as the accessory fuse. But let's try the daytime running lights. I don't know if you can see it. Yeah, there you go, 12 volts or 11 point something. So that has power. And same with the horn, which is the third one from the top, the 10 amp one. There you go, 11, 12. So that has power as well. So we've found our power source. I'm gonna turn my ignition back off. I don't need my voltmeter anymore. So ideally, I want to hook into my daytime running lights circuit, which is right here, the third one, 5 amps, or my horn circuit, which is the third one from the top, the 10 amps one here. So say I want to use my daytime running light circuit to trigger my relays that's going to power my aftermarket accessories, so they only power on when the ignition is on. I've seen it done this way many times. It's the easiest way to do it, but I don't like it because it's not really secure. Is to take out the fuse, get the wire that's your trigger for your relay, so for your relay coil that's powering aftermarket accessories, and then when you're inserting the relay, just put the wire in place as well. This will work because this trigger wire is getting power when this daytime running light circuit is also getting power. But this is not secure. If there's, this could easily come out. But I've seen this is the easiest way to do it. I've seen it done many times. The cleaner way to do it is actually to use something called a fuse tap adapter, and that's just a way to tap into the circuit without doing any of this exposed wiring or any of that. I wish I had one right now so I could show you how to use it, but it's super easy to use. I'll put some links in the description to some videos explaining what it is and how to use it. And that is a super secure, super safe way of tapping into any circuit, any of these circuits. But for the purposes of powering accessories and ignition, I would recommend using this daytime running light, or Posi lights as it's called here. And a fuse tap adapter is the way to go if you're plugging into the fuse box. Okay, yeah, so don't go digging around to find any wire under your seat, like for example this one, and use a voltmeter to find a 12 volt source. Don't do that because you don't know where that wire is going, or what that's powering and what that's used for. So be intentional about where you're getting your power from. Don't go around guessing, or don't just go around using a voltmeter to find any random 12 volts wire. So hopefully you guys found this video useful and you learned something, and now you're confident that you understand your bike's electrical systems and how they're designed, and you feel confident enough to add and wire up your own electrical accessories. If you have any questions, specific questions about any electrical accessories you want to add, or you have questions about this video, feel free to leave a comment in the comment section, or if I said something incorrect or if I missed something, please feel free to comment as well. It might have been a little slow for a lot of you guys who already know all this stuff, but for beginners who have been a little apprehensive about working on their bike's electrical systems, hopefully now you're no longer afraid to touch this. But yeah, hit the like and subscribe button if you like this video, and share this with your friends. And until next time, it's your boy Easy signing out. Take care, guys.